Okay, so in the 15th question, it is said that the train is starting from rest. So if I draw the diagram of its path, say this is the train, and at t equal to 0, the initial velocity of the train is 0. And now it starts with a constant acceleration of 2 meter per second square, and this happens for half minute. So that is for 30 second. So from 0 to 30 second, the motion of the type of motion of the train is uniformly accelerated. Further, after this, the brakes are applied. So at 30 second, the brakes are being applied. It means after 30 second, the acceleration is in the opposite direction. It is deaccelerating, and the speed of the train is decreasing. And they said it comes to rest. So it again brought to rest in 1 minute. So in 1 minute means the time interval from 0 to this is 30 second. While after applying brakes, it comes to rest in 1 minute, yani ki 60 second. So the time instant here would be 90 second, because the time instants are 0, 30 and 90. Okay. Now, as I said earlier also in the previous problems, if object performs more than one type of motion, then always solve that particular numerical by using velocity time graph. So I will go for the velocity time graph. At t equal to 0, the velocity is 0, while it is having a constant acceleration, so the velocity will go on increasing for a half minute, that is for 30 seconds it will achieve certain velocity. Further, at 30 seconds, the brakes are being applied and it is come to halt in next 1 minute. So in the next 1 minute means the time instant here is 90 seconds. Okay, so this is the velocity time graph of the train. Find the distance traveled by the train. So distance is nothing but area under velocity time graph. Okay, for this we need to find this coordinate, that is velocity at this instant. So no problem, we can find the velocity by using v is equal to u plus at. Starting from rest, acceleration is 2 for half minute, that is 30 second. So it comes out to be 60 meter per second. So this is 60 meter per second. Now in the first bit it is said that we need to find the distance. So distance is nothing but the area of this graph, so which is the area of triangle, half into base, the base is 90, into height, which is 60. So 2 3s are 6, 0 and 3 9s are 27. 2700 meter is the answer for our first question. Okay. Second, what they asked, maximum speed attained by the train. So you will see that in the velocity time graph, from increasing 0 to 30 second it increases and then it decreases. So whatever the velocity achieved at 30 second is maximum. So the maximum magnitude of velocity is, or speed is, 60 meter per second, and this occurs at 30 seconds. The position of the train at half the maximum speed. Okay, so when the maximum speed was half, that is 30 meter per second, then and in that case what is the position of the train? So no problem, we have to find area of this graph. Okay, because the train is starting from x equal to 0, so we need to find the position. No problem. So again I can say displacement is nothing but area under the graph, so it is half into base. So what should be the base? So at what time velocity would be half? So again the velocity is increasing uniformly, so that's why I can say if this is 30 second and half the time, half the maximum, so what is the velocity? So when velocity will become 30, so 30 is equal to u plus at I will apply. So 30 is equal to 0 plus 2 into t, so t comes out to be 15 seconds. So this time instant is 15 seconds. Half into base, which is 15, into height is displacement. And what is displacement? Final position minus initial position, and this comes out to be 225. While what is the final position? So initial position is 0 because train started at x is equal to 0, that we have assumed. So what is the position of the train? So the position of the train is 225 meter from starting point, or directly displacement also we can say, because when x is 0, it is started from x equal to 0. So these are the answers for this question. Thank you.